Welcome to this informative video on the diffraction of light. In this presentation, we'll delve into the phenomenon of light diffraction, its wave-like characteristics, and the two main types of diffraction. When light waves encounter an obstacle or pass through a narrow opening, the light waves bend around the edges of the obstacle or opening and spread out. This phenomenon is called diffraction. Diffraction can be observed with all types of waves, including sound waves, water waves, and electromagnetic waves such as light. Diffraction of light demonstrates the wave-like properties of light. When light waves encounter an obstacle or slit which is comparable in size to the wavelength of the light waves bend around the edges of the obstacle, creating a pattern of alternating dark and bright regions known as diffraction patterns. According to the Huygens-Fresnel principle, every point on a wave front acts as a secondary source of waves. These waves from different parts of the opening interfere, and produce the diffraction pattern on the screen. This pattern indicates that light is behaving as a wave, interfering constructively at some points and destructively at others. The bright bands are regions of constructive interference, where the crests of the waves meet the crests of the other waves, which means that the waves are in phase and add together to create a larger wave. For destructive interference to occur, the waves must be out of phase by 180 degrees. This means that the crests of the waves must meet the troughs of the other waves. The amount of diffraction depends on the relative size of the wavelength of light to the size of the opening. If the size of the opening is much larger than the wavelength of light, the diffraction will be almost unnoticeable. However, if the opening is comparable in size to the wavelength of light, diffraction will be significant. The smaller the size of aperture or obstacle and the longer the wavelength, greater will be the diffraction. The greater the size of aperture and the shorter the wavelength, lesser will be the diffraction. There are two types of diffraction, Fresnel and Fraunhofer. In Fresnel diffraction, the light source and the screen are relatively close to the obstacle. This proximity results in complex diffraction patterns. On the contrary, Fraunhofer diffraction occurs when the source and the screen are at larger distances from the obstacle. Fraunhofer diffraction patterns are simpler and easier to calculate mathematically, making them valuable for various applications. We hope this video has provided valuable insights into the intricate world of diffraction of light. Thank you for watching.